In today's lesson, you will learn to simplify powers having fractional or rational exponents. The rules are the same as the ones that you learned earlier for integral exponents. In other words, to multiply two powers that have the same base, one keeps the base and adds the exponents. To divide two powers that have the same base, one keeps the base and subtracts the exponents. To raise a power to a power, one keeps the base and multiplies the exponents. If one has an exponent outside the parentheses, then the exponent applies to all of the factors and the divisors inside the parentheses. I'm going to give you the rule that I've just stated in symbol form as your first frame. I put a star on it in case you did not list it before. Let's let x and y be real numbers and let a and b be rational numbers. X to the a times x to the b is x to the a plus b. In other words, to multiply powers that have the same base, keep the base and add the exponents. X to the a divided by x to the b is equal to x to the a subtract b. In other words, to divide powers that have the same base, keep the base and subtract the exponents. In this case, we do have to assume that x is not 0, or else we would have a division by 0 error. To raise a power to a power, you keep the base and multiply the exponents. So we have a power, we're raising it to a power. We keep the base, multiply the exponents. If I have an exponent outside the parentheses, then the exponent applies to all of the factors inside the parentheses. The exponent a applies to the x, the exponent a applies to the y. The same is true for division. If I have x divided by y raised to the a power, the exponent a applies to the x, the exponent a also applies to the y. If you have not already memorized those properties, be sure you do so now. Let's look at some examples using the properties. Let's consider 2x to the 1/3 times 6x to the 3/2. Since we have multiplication, I can regroup and reorder any way I want to. So I'm going to group the 2 and the 6 together. I'm going to group the x to the 1/3 and x to the 3/2 together. So I have 2 times 6 times x to the 1/3 times x to the 3/2. Of course, I can multiply 2 times 6 to get 12. And I remember that to multiply powers having the same base, I keep the base and add the exponents. 1/3 plus 3/2. Keep the base, add the exponents. 1/3 plus 3/2. In order to add the exponents, I need to find the common denominator. The common denominator between 3 and 2 is 6. 3 goes into 6 2 times. 2 times 1 is 2. 2 goes into 6 3 times. 3 times 3 is 9. Now once I have the common denominator, I complete the adding process by keeping the denominator and adding the numerators to get 12x to the 11/6. Now let's look at a division problem. Similar problem, using the same numbers, but we're going to divide. We have 2x to the 1/3 divided by 6x to the 3/2. Some of these exponents are hard to read on the screen, so you need to listen carefully as I tell you what they are. So it's 2x to the 1/3 divided by 6x to the 3/2. Now I can go ahead and reduce the 2/6 as usual. 2 goes into 2 one time, 2 goes into 6 3 times. And remember that to divide powers having the same base, I keep the base and subtract the exponents. So it's going to be base x, exponent 1/3, subtract exponent 3/2. To subtract the exponents, I need the common denominator of 6, so I can write it as the 1/3 x to the 2/6 minus 9/6. Again, 3 goes into 6 2 times. 2 times 1 is 2. 2 goes into 6 3 times. 3 times 3 is 9. Now doing the subtraction, I get 2 subtract 9 is -7. So we have 1/3 x to the -7/6. Now you need to remember that a negative exponent tells you to take the reciprocal of the base. So I would have 1/3 x to the 7/6. The 3 is already in the denominator. I have a negative exponent. It tells me to take the reciprocal, so the x is moved to the denominator. So the answer is 1/3 x to the 7/6. Now notice the negative exponent tells you to take the reciprocal of the base. It doesn't mean to take the reciprocal of the exponent. It says take the reciprocal of the base. So the base went to the denominator. I still have 7/6 as the fraction. Let's look at one in which we have an exponent outside the parentheses. Let's simplify 8x cubed y to the 1/2 to the 1/3. The 1/3 is the exponent outside the parentheses. The exponent outside the parentheses applies to all of the bases inside the parentheses. So the 1/3 goes with the 8, the 1/3 goes with the x cubed, the 1/3 goes with the y to the 1/2. So an exponent outside the parentheses applies to each of the factors inside the parentheses. Now we know that 8 to the 1/3 is the same as the cube root of 8, and the cube root of 8 is 2. That's what you had in the last tape. 8 to the 1/3 is the same as the cube root of 8, which is 2. To raise a power to a power, I keep the base and multiply the exponents. So it would be x 3 times 1/3. And again, I'm raising a power to a power, so I keep the base y, multiply the exponents. So it would be y to the 1/2 times 1/3. Now this is understood to be 3/1. So then I do the multiplication to get 2x to the first, y to the 1/6. So it would be 2x, that would be 3/3. 3/3 is 1. Y to the 1/6. 1 times 1 is 1. 2 times 3 is 6. I can rewrite it as 2x y to the 1/6 because x to the first power is x, and that gives me the answer. Let's look at another example. In this case, we're dealing with literal exponents. We have x to the 2/n times x to the 5/3n. But the big thing is I am multiplying powers that have the same base. To multiply powers that have the same base, I keep the base and add the exponents. So it would be 2/n plus 5/3n. I need a common denominator. The common denominator between n and 3n is 3n. Now what do I multiply n by to get 3n? The answer is 3. So what do I have to multiply the 2 by? So I need to multiply it by the 3 also. 2 times 3 gives 6. Here I already have the common denominator. Once I get the common denominator, I keep the common denominator and add the numerators. 6 plus 5 is 11. So my answer is x to the 11/3n power.